demonstrates two methods of reconnecting an inverter to a small microgrid. In the first method, enabling PI1 and PI2 when the state switches are in position 1 makes the output frequency of inverter 2 the same as inverter 1. Notice the circuit breaker is open and only inverter 1 feeds the load. At this moment, the circuit breaker is closed and the state switches are transferred to position 2 to achieve power sharing. Equal power sharing is achieved now, as both inverters have equal droop coefficients in this setup. Any further change, increase, or decrease of the load can be shared equally and seamlessly as seen here. We refer to this strategy as the output sync method. In the second method, the circuit breaker is closed. Inverter 2 follows inverter 1's frequency but operates at zero power. The state switches in the controller are in position 1. Two control sets are run in parallel, as shown in the control block diagram. Enabling the PIs 1 and 3 in the control scheme makes the voltage magnitudes and angles, the outputs of the parallel paths, identical. When the control sets are synced, all the state switches are transferred to position 2 to achieve power sharing. Now both inverters are in grid-forming mode. Notice the output angles of two control paths needed to match only when switching from position 1 to position 2 happened. The PI5 in the block diagram was enabled before transferring the switches to position 2 in order to zero the difference of angles that may exist during the process. Any further increase or decrease of the load can be shared equally, as both inverters have equal droop coefficients in this setup. We refer to this strategy as the controller sync method.